right, welcome back. So we're going to continue talking about solving systems of equations. We're going to look at two separate methods today, substitution and graphing. So I want to give you the reminder again, take this chance to pause, either print the guided notes or make sure that you're writing down the different equations and notes to get started with, pausing whenever you need to so that you're not feeling like you're being rushed. Once again, subtitles are available down here if you want to turn that on. So, substitution method is another way that we can solve our system of equations, and we know we're going to want to use substitution in this case compared to yesterday. You'll notice that our x terms here are not the same. So substitution is where you solve for the similar variable, like our y's in this case, and replace. So as I noted, in this case our similar variable is y, so I'm going to just take this first equation and solve for y by subtracting our x squared. So this first equation can be rewritten as y equals 9 minus x squared, and then we want to replace that into the second equation, so then we will have an equation that just has a single variable. So when we replace, we get x minus, and notice I'm going to put parentheses, y is now the same as 9 minus x squared, plus 3 equals 0. So again, taking our solved equation and plugging it in here, and we end up with a new quadratic where we're just looking at x. And I put the parentheses in here when you substitute, because you'll notice that often it affects things like negatives. So when I distribute and simplify, we get x squared plus x minus 9 plus 3, which is 0, or x squared plus x minus 6 equals 0. And this should feel like a pretty traditional quadratic, x plus 3, x minus 2, and so then our two solutions for x are negative 3 and 2. Now, because we have two solutions for x, we're going to end up with two solutions for y. So we have our two solutions here, x equals 3 and x equals negative 3 and x equals 2. And one thing I like about the substitution method is that we already have an equation that's very well set up for us to find y. So I'm going to substitute our x values in both of those. So for the first time, y equals 9 minus, again parentheses whenever I substitute, or here y equals 9 minus 2 squared. So in our first equation, we get 9 minus 9, so then y is equal to 0. And our second, we get y equals 9 minus 4, so y equals 5. As we said, the answers here are often written as ordered pairs, so we get negative 3 for our x value, y for our second, and our second solution, which makes sense because we had a quadratic. It makes sense that we're going to have two solutions, is 2, 5. So that's the substitution method. Next, we're going to look at the graphing method, and as you can see here in the notes, you're going to want to have your graphing calculator available to you. So if you haven't gotten it, pause the video now and go grab that. So with the graphing method, all we want to do is graph the two curves and just find their intersection points. So since we have a graphing calculator, that's pretty straightforward. Now, the first thing with your graphing calculator is you're going to want to have your equations all equal to y, like we see here. So our second equation's already set up for that, but we need to solve our first equation. So what I would do is add y squared to both sides, so this equation becomes x squared equals 3 plus y squared. Subtract the 3, x squared minus 3 equals y squared, and then take the square root Remember, it's subtraction, so we can't simplify that x squared, so it's just plus or minus x squared minus 3 equals y. So we've set that equal to y. Now we want to graph those in our calculator. So in your calculator, in order to put in and deal with the plus or minus, what we're going to end up doing is we're going to start off with our first y equation. For most of you, this will look like that, and we're going to put in our x squared minus 2x minus 8, and that's going to be just fine. For the next one, we're going to put in two separate equations. We're going to have the positive x squared minus 3. Make sure that you're including parentheses if your calculator needs you to do that. And then we're going to have a third equation, which is the negative root x squared minus 3. So in this case, you're actually going to have three equations and two separate ones, positive and negative, to deal with this plus or minus. And then you should end up with a graph slightly similar to this. Not all of you are going to have the nice color coding, but you should all have something similar where you have the parabola from that equation here, and then your positive and negative to create this hyperbola. Now, for most of you to find these intersection points, you'll notice that there's 1, 2, 3, and 4 here. Whoop, oh, that's showing up. There you go. To find the intersection points, for what most of you are going to do is you're going to want to go to second trace, just like finding a minimum or maximum. And then you're going to want to find intersect. Once you pick that, what it'll do, it'll ask you to find the first curve and the second. So using your dial, scoot over so that you're kind of close to the first point you want to find. Let's say the first one we want to find is this one in quadrant 1. So you want to make sure that you're close to this one. So it'll be like, okay, first curve, click enter there, and then it'll immediately jump to a nearby one. If it doesn't jump to this positive one, just click with the arrow button to get to that one if you need to. And then, so once you have your first curve and your second curve near the point that you're looking for, that's when you'll want to click enter, and it'll tell you what the point is. You'll have to do this for all 4 points here, but once you have it graphed, it doesn't take all too long. Just make sure that you're near the point that you're interested in before you start selecting your curves. And you can use the arrow keys that are going this way to move that browser point so that you can be near to our points in the second, third, and then fourth quadrant. All right, so those are the two other methods for solving a system of equations that we're going to talk about for today. Be sure that if you have any questions, leave them in the comment section below. And if you haven't already, complete your check-in. That will be reviewing the elimination method as well as other review topics. I'll see you tomorrow.